Okay, so now we're going to be talking about Fourier series, which are a way to represent periodic functions as a sum of sine and cosine. So, according to Fourier series, whenever we have some kind of alternating signal, square waves, sinusoidals, triangular waves, or this is called a sawtooth, we can always represent them as a sum of sine and cosine according to Fourier series. Now, unfortunately, I might not be in too much to. There's not much to say about Fourier series, other than that they are pretty much the periodic version of Taylor series. So actually, pulling up on Wikipedia, we can actually talk about this a little more. So Fourier series, as you may see right over here, are a way for us to construct periodic functions using an infinite number of sine and cosine terms. Here, if we have many special properties and cases. The most important case, at least in the context of electrical engineering, would be Parseval's theorem. The idea of Parseval's theorem is that we can represent a time function we can calculate the power of a time function by looking at its Fourier transform. We'll look at Fourier transform a little more, but just in general, here are some definitions for it. We can use the amplitude phase form. We can convert between Cartesian and polar. We can use the sine and cosine form, and we can use the exponential form. When it comes to constructing any kind of periodic waveform, the sine and cosine form would be the best for this situation. However, if we're just using in general for talking about Fourier series of something, it would be best to use the exponential form. And here are just a few examples. I won't go too much into it, just that the idea is any kind of periodic function would represent a way for us to, or any kind of periodic function can be deconstructed into sum of sines and cosines. Much like how for Taylor series, any continuous function can be deconstructed into a sum of polynomials. It is a very similar concept, and this is just another way to do so. In the next video, we're going to talk more so about the important part of Fourier, which is Fourier transforms. All right.